We are still in chapter 3 about AWS, Amazon Web Services, and we took an example. This time it's another example about using AWS. So here it shows, in the previous example, it shows how easy it is to create and access variables in your code. Now that we have completed Hello World demonstration of Lambda, in the previous example, we will look at creating a new application that uses an HTTP event and responses to it by returning data from DynamoDB. So this will be the second one, that it's about creating an application that uses HTTP event and responds to it by returning data from DynamoDB. HTTP event. For our first fleshed out serverless application with Lambda, we are going to use AWS API Gateway. So what we will be using here, AWS API Gateway, for what? To trigger Lambda function that returns data from DynamoDB NoSQL database. API Gateway allows you to create HTTP resources and methods and set them to specific endpoints. API Gateway allows you to create HTTP resources and methods and set them to specific endpoints. This application will mimic a virtual recipe. This application will mimic a virtual recipe book. We will create an API gateway with one resource, recipe, and one method that resource get for that resource. So just one resource, it's called recipes, and for one method, it's called get. So it's pretty simple for the sake of learning, right? For the endpoint to this get request, we will set a Lambda function. We create get recipes. This function will access a DynamoDB table that will have a pre-populated with recipes and returns a JSON. They call it JSON value of these recipes as the response. So what will be returned? Something called JSON value or JSON value, right? Before setting up our API gateway, we will go ahead and create our Lambda function, leaving the trigger and code blank for now. Once you have done this, you can move on to exploring API gateway. Exploring API gateway. API gateway is an AWS service that lets you easily to create and access an API all through the API gateway console. It gives you a public RESTful API interface to a wide host of AWS services. This allows you to interact easily with your databases, messaging services, and Lambda functions through a secure gateway. In addition, it is incredibly easy to set up and create endpoints for. This allows the continuation of rapid development. To begin using API Gateway, navigate to the API Gateway service under Application Services. The API Gateway console shows your API, usage plans, API keys, custom domain names, client certificates, and settings. Again, the API Gateway console, Amazon API Gateway, right? Shows your APIs, usage plans, API keys, custom domain names, client certificates, and settings. Figure 3.20 shows an example of the API Gateway console, and this is 3.20. To create an API, simply click Create an API. This will take you through a process of setting up your own API. We will create a new API name. We'll create a new API and name it Recipe API. After creating your API, you should be directed. After creating your API, you should be directed to a console that allows you to configure your API. We want to add resources to our API called recipes. So this will be the next one. The new child resource can be added at your API resource and will be used in the request URL. So new child resource. This is Amazon API Gateway, right? Resource name recipes. Path recipes. You can add path parameters and so on, right? Resources allows you to have multiple objects for your method. We also want a single get method attached to our resource. Figure 322, this one here, shows what your API console should look like after configuring the endpoint. Right. We then need to configure an integration for our get method. You can have Lambda create an API gateway endpoint for you, but doing it this way gives you control over what the endpoint looks like and its configuration. For this, we want to select Lambda function, specify region, select our get recipes Lambda function. This tells the API gateway when the get method is accessed to execute the Lambda function. Figure 323 shows the complete integration of the Lambda function. And here's the complete integration. So here is the get method and method request, method response, integration request, integration response, Lambda get recipes, right? API gateway allows you to view each method execution within your API. Before going back to Lambda console to set this API as your trigger, we need to deploy our API to a stage. Staging is important for version control and deployment. Again, staging is important for version control and deployment. Since we are still in development, we are going to name our stage beta. Depends on your naming it, whatever, right? Under actions, next to resources, click deploy. The pop-up shown in figure 324 will ask you to create a stage if you haven't already. Go ahead and create a new stage and name it beta. Stages represent a unique identifier for a version of a deployed REST API that is called by different users and services. And here is 324. After deploying it, you will be directed to the Stages tab, figure 325. This is where you configure settings for your stage, stages, so settings for your stage, stages variables, SDK generation, Swagger, export, Postman extensions, deployment history, documentation history. Take a look at each of these tabs and see everything that is available to you through API Gateway. Note, Swagger, that's mentioned here, Swagger exports. Swagger is an API framework that allows you to easily view and interact with your endpoint. I like it because it makes easy to test your services and is also simple to add to your project. And here's 325 mentioned earlier. Beta stage editor, right? We're still in the Amazon API gateway. At this point, we have an API gateway with one resource and one method deployed to a beta stage and integrated with our Lambda function. All right, we have done all this in the previous few pages. We are ready to set this API as our trigger for our Lambda function and begin responding to requests. So all these steps are required before setting this API as our trigger. Note, you might be wondering why we are only giving our API one method. Earlier in this book, we discussed the importance of each function having a single task and triggering event. We can add multiple methods to this API, but we would also want to create multiple Lambda functions to respond to different requests. For example, a Lambda to handle post requests, a Lambda to handle delete requests, and so on. So this one was only for the get. Using API gateway as a trigger. Back in the Lambda function get recipes, we can now configure API we just created as our trigger. Under triggers in our functions, click add trigger. Here we can select, so go to the function, right? Lambda functions, all right? Get recipes, add trigger. We select API gateway from the drop-down menu and specify API we just created. This tells our Lambda function to wake up to event coming in from this specific service. Why did we select the API we just created? To tell Lambda function to wake up, to tell our Lambda function to wake up to events coming in from this one. All right. Figure 326 demonstrates the correct configuration for our function, and here's this figure. Leaving the Lambda code as is, we can go into API gateway and test our trigger by clicking Get Resources. We can select Test and test our API. Since it is a GET method, it requires no request body. On the right in API gateway, you should see a response, status, and latency. You could also view this in the browser by just hitting get point. The URL for this example is this. The URI, right? And here's 327. Now that our trigger is configured, we can develop our Lambda functions to respond to this request by returning recipes from a DynamoDB table. To do this, we first create a DynamoDB table. So first we create a DynamoDB table. Recipes and populate it with some recipes. All right. Use the Services tab to navigate to the DynamoDB services. Here we can click Create Table and name our table recipes and assign it a primary key of ID of type number. The primary keys should be unique to items. The DynamoDB table consists of items and attributes. In our table, each item is a recipe which has attributes of meal, description, and prep time. An empty Dynamo table with a primary key of ID. DynamoDB. All right. Create table. Yeah, just like that. From here, we will create a couple of recipe items to populate our table. To do this, click Create Item and append fields, meal description, and prep time with various values. This figure demonstrates how to append fields to an item. When our table has been populated with a couple of recipes, we can build our Lambda function to return these recipes in response to API. To create the Lambda portion of our serverless application, sorry about that. To create the Lambda portion of our serverless application, we will be using TypeScript, Node, and NPM. The next section will go over how to accomplish this. Response to trigger. For our Lambda function, we will be developing within Visual Studio Code using TypeScript, Node, NPM, and the AWS SDK. First, it's important to format our project structure so we can easily zip and deploy our function. Figure 321 shows this structure. I have chosen to create this Lambda function within our AWS project. I created HTTP trigger project and a shared folder and get recipes folder. The get recipes folder will hold our handler.js file, which will be triggered by the get request, and the shared folder contains the recipes model that defines the structure of the incoming request. And here is the proposed project structure for HTTP event. For now, we will create the function without using serverless framework. So outside the HTTP trigger project, we will need a package JSON file to specify what npm installs, and ts configure.json file to configure our TypeScript builds. Your package.json file should include AWS-SDK and TypeScript as dependencies. The complete package.json file for this application. TypeScript. AWS SDK. AWS SDK. And the dependencies. The ts config.json should be configured to build on save and to compile on save. This will compile the JavaScript file for TypeScript files as you save. And here's the TypeScript file excludes the node module, VS Code, Git, and serverless files in its build. We can now do an npm install in our project to install all of the node modules. We will need to create our Lambda function again. We can now do an npm install on our project to install all of the node modules. We will need to create our Lambda function. This will create a node module folder, node modules, node underscore modules folder in our project with all of its dependencies. We also create recipe model.ts file. In the shared folder, this model will define the structure of the recipes we create in our Dynamo table. We can then use this in our handler.js file to format our response to the GET request. In the future, with other requests, you can use this model to format the request. Right? And we can proceed in our handler.ts file. We will create get recipes module that will take in an event, right? And here's the listing 3.4 demonstrate this handler function. All right. All right. Import the AWS SDK and recipe model. Create a DynamoDB client to communicate with the table. Utilize environment variable for the table name. Set the response of the message. Create the table connection with the parameters, table name, expressions, attributes. Format response to scan. We can now compile our TypeScript files into JavaScript files. Once we have created the handler model, node modules, and compiled our TypeScript, we can compress and upload our application. It's important to remember that the handler.js file must remain at the root of your compressed files. The compression must occur at the level shown in figure 332. All right. After uploading the zip file to our get recipes lambda, there are still a couple of configurations to take care of. First, we need to update our handler. Our handler should now be listed as handler.getRecipes. This is because the module we are exporting is called getRecipes, and it is found in the handler.js file. We should also get our environment variable table name with its proper value. We also need to add a policy that gives us access to DynamoDB to our Lambda role. This can be done in WSIAM under roles. All these can be done, right? Finally, we can test our Lambda function using Postman and the URL given in the API staging console. Figure 332 demonstrates Postman request and the response we get back. So here's Postman. We use the URL provided in the API gateway to make a GET request. Our response is a JSON response with all our recipes listed. We now have to start to finish serverless application using API gateway, Lambda, and DynamoDB. We now have a start to finish serverless application using API gateway, Lambda, and DynamoDB. By now, it's done, right? Improving our serverless function. Improving by separating logic and utilizing serverless framework. Separate AWS logic from handler. Use environment variables for AWS specific logic or move AWS logic to shared folder. Create services folder that is specific to AWS and serves DynamoDB. Utilize the serverless framework. Follow instructions for AWS setup and serverless framework. Develop and deploy functions using serverless instead of manually. The code for both of these improvements to the project can be found here. And here's a link, right? In the next video, we'll be talking about storage event to trigger a Lambda function that responds to the put request. This will be in separate video. It's like the third example related to the AWS. See you then.